All right, good morning. I know it's a quick turnaround from the last panel, but thank you all for being here. And welcome again to day 2 of the 2020 MIT Sloan Sports Analytics Conference. These are the competitive advantage talks, which are all sponsored by the Craft Analytics Group. And it's my honor to introduce the following competitive advantage talk. It's titled Instant Feedback, Using Real-Time Data to Improve Training, Case Studies from the MIT Sports Lab. This talk is going to be presented by Christina Chase. Christina is the Managing Director and Co-Founder of the MIT Sports Lab. And with that, I'll turn it over to Christina.
Thanks, Colby. Thanks. Good morning.
One additional note. Sorry, one thing I forgot. One additional note. When we get to the Q&A at the end of this, please wait for the microphone to be passed to you. Okay, we're not going to be able to hear you, so just wait for the runner to bring you the mic. Thank you.
You all have your instructions. My name is Christina Chase. As Colby mentioned, I'm the Managing Director of the MIT Sports Lab. I'm also a lecturer in the School of Engineering at MIT. Today, I thought we'd talk a little bit about trying to get data into the real-time feedback loop that naturally takes place during training. So how many of you can remember the last time you tried to learn a new sport? So it's typically an interesting endeavor. Perhaps you've got somebody telling you, fall over, off to your side, or yelling from behind you, stop leaning back in your skis. Or maybe you decide, without a coach, to take your skills on the road to see how well that's working for you. We've all been there. Athletes are in a constant state of trying to do this. But now imagine getting feedback 10 days later on that training run or that session. Remember 2 Tuesdays ago, on your third run, you should have done more pizza, less leaning back. Remember that? This is what today's athlete sometimes deals with. We have to think of training as a process, a system where everything needs to work. So, the action's taken, it's understood, they give feedback, athlete repeats action. When using technology, it may look like this. Something captures action, there's processing. That coaching is then able to be taken place or used, that information's used. Try again. Whether it's wearables, video, maybe clicks in esport, then there's a lot of manual tagging today, but maybe you're trying to have auto event detection or pose estimation. Maybe the coaching is human, maybe it's digital. And then those specific movements may play out as drills, an actual technique, maybe a full play. The challenge is that many times today with the technology that we're using in training sessions and through the analytics approaches, there can be a breakdown because very little of what is captured and processed is actually put back into the immediate feedback loop, such that the athlete is getting so remember 10 days ago when you... So we've done 2 projects at the Sports Lab to try and help with this. First, I'll talk about one with the US Olympic Committee in the processing phase, and the second with Red Bull High Performance in the coaching phase. First, this was done with track and field, specifically on the long jump. They take high-speed video of all of the training sessions for their jumpers. To be able to detect launch angle and velocity, this is done manually today. Of course, one might say, well, just put something on the athlete. No, We cannot put stuff on the athlete. And the second, typically, is it has to be done, like it has to be processed and back into the feedback loop during that coaching training session. So that means it cannot be even an hour later. It really needs to be near real time. So the question is, can we automatically detect the exact time when a long jumper's launch takes place? For those of you who are active long jumpers, you know there's a three-phased approach. There's pre-jump, the actual jump, post-jump. So what we looked to do was go from taking this very manual process and detect the jumper and its joints, quickly calculate the jumper's center of mass, total center of mass, detect that launch frame, and then calculate launch velocity and angle near real time. Okay. Guess how many points on a body need to be identified for total mass to be detected? Typically, we tell all of our students, do not put up tiny font. But that's because this is right now what a coach might see. There are 19 individual locations that every frame has to have identified. For the long jump, typically there are 50 to 100 frames for just the jumping motion. For each of those, then, you've got 19 points that must be identified. And so you're looking at approximately 2,000 points that need to be done per frame by hand. So when we say it's a bit tedious, it's no small task. That's all right, just throw a group of grad students on it. They'll love it. But imagine not being trained to actually know even where exactly that joint is. So these types of manual types of tags can also vary by whoever's doing the manual tagging. So the question is, let's just speed up the process. There's a lot of open pose tools or pose estimation tools out there. But as you can see, can you tell the exact moment there where the frame is taking off, where actual launch takes place? As you'll go back, you'll notice in here what is typically the last thing to take place in launch is the left toe. Very clear, right? So, as we go through this, the team worked to try and use these open source tools to be able to quickly extract. Now, as going through this, you can see that that little dot is over the exact time of launch, which intersects with both phase 1 and phase 2, which means the computer says, what? So if we go back, the others, this is the open pose, will process every frame individually, which means every single time it looks at a new frame, it re-identifies everybody in that frame and gives it a new reference number. In addition, it has identified 11 people, one being the jumper, and when it exports every frame, it has done the reassigning of every dot and every individual randomly. So you can appreciate that it comes out like junk. But as we went through there, we were able to get an algorithm to define the largest signal and then quickly be able to get to a refinement of quickly being able to detect that exact launch and progressively reduce the error rate, which was typically the left toe. Now, there's still small errors. We got to about 99% accuracy, but we need a few more left toes to really complete this out. Case 2. So I talked about human coaching, but now we're going to go into esports. Red Bull High Performance has stood up esports within their high performance group. We hear a lot, we'd like an AI coach. But as we start to think about this, where's a good place to start with that? And typically you think, oh, well, just repeat whatever I think my best coach does and we'll just feed the algorithm that. Well, in esports it's actually perfect because we have every single click for every single movement. And so what we did was looked at what might that look like in esports as a starting point. But first question is, I'm going to build a digital coach. What should it even do? What we did was we looked at some research that Stephanie Mueller had done over in CSAIL. And she had actually been able to prove out that when using dynamically adaptive inputs, you're actually able to increase the rate of skill acquisition. So that's what we did. The question is, what does adaptive rate even mean? So, with a control group, we defined a very specific play in a Super Smash Brothers called the wave dash, which is a very complicated, quick set of movements. And we had a control group, an adaptive group, and a granular group, whereby control, of course, no game speed, but adaptive, we were going up 10% if you were 60% successful for a session of 7 moves or tries of this move. No change at 60 to 40, or slowing down if you're less than 40% successful. Okay. For granular, we really tried to emphasize how fast we're going to speed things up, as well as how quickly we'll slow them down. So we've got 10%, if 60% successful, 20, if 100% successful, no change, 40 to 60. Now, if you're less than 40, we'll slow it down by 10, but if you're less than 30, if you are only 40 success or less than 40% successful, we'll slow down by 10. And if you are really having a hard time, we'll slow down by 30. Okay. We took beginner, intermediate, and experts of being able to do this move. And believe it or not, we saw the largest increased skill by our experts at the granular stage. And you notice that the adaptive, at only 10%, actually, most people came out worse. So why is that? Most people couldn't tell the difference for the 10%. It was too subtle. But here's the thing. We're really bad about knowing when to make things harder for ourselves or when to back off and make them a little easier. But if you can automate that, then you're automatically able to detect when to really push skill acquisition and when to back off and say, okay, we're going to let you break this down, slowly practice it, and then we can more quickly increase the speed at which that skill is trying to be executed upon. Going back, as you notice, so triangles are the granular, adaptive is the square, control groups are circles, and you quickly can see at the expert level this significant increase at the granular level. Trust me, none of us thought we'd see that. So these are just a few of the examples of the types of questions we work on at the Sports Lab. We are constantly being asked, how do we make the best use of all the incoming data streams coming both on and off the field, coming in on and off the field? Another one is, what data should we even be collecting? There's a lot of siloed data today that folks would like to be able to put together in a more holistic approach. how can we maximize the fan engagement and place that into revenue, or translate that into revenue, and many more. We do this across sports, so we have the unique opportunity to be able to see some of the big trends, and that's where, as we see feedback from the data becoming more real-time, it's something everyone can take advantage of. Thank you. Okay, don't forget your instructions. Wait for the mic.
Thank you for your excellent presentation. On the second study you outlined for gaming, have you considered, in looking at different levels, where your beginners, intermediates, and experts, where they were looking, and maybe the use of looking at eye tracking technology, you could differentiate experts from beginners from looking at cue utilization?
Certainly. Excellent question. So for this particular area, the game is happening, or the actual move is happening in a very small location on the screen. That said, especially for some of the work that we're doing in decision making, when you've got a wider field of view, that's very interesting, because then you can start to map out how fast they're choosing to go, for example, to their next option within maybe a play call. Eye tracking is interesting. It can also be a bit expensive when trying to prove out kind of proof of concept. So we always try to think about how can we do this as cheaply as possible in a way that will give us clear indicators as to whether or not to go to that second layer. But it's an excellent question. Eye tracking is interesting.
Hi. Regarding the track and field long jump example, two questions. One is, what's an example or two of specific actions that you anticipate the coach would take upon seeing the automated analytics in real time? And the second question is, what other track and field events do you think might be interesting to also apply the technology to?
That's a great question. So before taking this project on, we did not realize how complicated the motion of a long jumper actually is. So I would say for the pre-jump and actually going into launch, they're looking to maximize the total center of mass to travel as far as possible. And so when they're looking, they'll look, we've got hundreds of training videos, right? But they're looking at kind of what is the best biomechanical position for that particular jumper, for the distance they achieved, for kind of what is seen as the optimal position when they're in takeoff. And so what they're telling them is stuff like, well, bring your elbow faster through the move, try and pull your hip a little bit faster through to actually start to initiate the movement to get that center of mass like tucked under and over. So, I mean, in the coaches, coaches at this level, or any professional elite level, I mean, they're seeing things that none of us would typically see. But this allows them to also better explain to their athlete what exactly they mean when they say try and swing your elbow through a little bit, because they can also go back to other video. The USOC wants to apply this to everything. For example, synchronized diving. So can we best match who have the most similar rotational speeds when we're doing the pairing of divers? Right now, they're putting a sensor on the ankle, but even then, ultimately, what we're all trying to get to is nothing attached to the athlete. So, great question.
Hi. When you have something as subtle as move your elbow a little bit like this, have you ever noticed, as part of the whole training regime, what I think it's called the centipede's dilemma? You tell someone, hey, how do you keep your foot to go in this angle? And suddenly that's all you're focusing on, and you start tumbling forward. How do you know that the data you're providing is able to apply in a way that's not going to psych out whatever athlete you're trying to get it to apply to?
This is why we will not replace coaches. Coaches know when to filter and what to say. So what we look at, we don't look to build a tool to give them absolutely everything. We have the coach define what exactly they're looking for. And so you saw those like 19 tracers of the entire body. I mean, the coach doesn't want that. That's not useful. So what we would do is the UI would, for what they were particularly wanting, it's just give me launch angle and a video and like the exact frame so that I can refer to. And then they'll choose whether or not to use it or apply it. But it does need to be real time.
Does the analytics simply facilitate the work of the coach, or does it also discover new trends and new phenomena that were unknown by the coach?
So analytics, the way we look at technology and analytics is it's a tool, not an answer. And it can be used in many parts. So whether it's in the training or development phase, be it in game strategy, athlete health and performance, it's ultimately, yes, certain types of data can give you new trends and new insights. It could help with coaching, right? Again, it really just needs to be defined around what is the question you're trying to answer. And if you knew that answer, magic wand, now what? Now what will you do with it? And so I think as we have this explosion of data, it's also starting to be really thoughtful about the filtering process and really understanding what are you trying to answer first, and then does the data perhaps give you some of those nuggets?
Christina, thanks for the time. After watching the short clip in your presentation, the first thing that came to my mind was motion capture technology may have solved some of the tagging issues. So I guess my question is, why was not putting anything on the athletes such an emphasis?
The USOC said, do not put stuff on our athletes. And as we talk to pro teams, are you going to ask LeBron to wear sensors up and down his body, right? Ultimately, the passive collection of this type of movement is really where we see the future and that things needing to be done. And the other piece is, if you're a long term, they've got a very finite amount of time to train. They don't have time to have the athlete suit up, because it also matters where the sensor is located on the body for consistency, calibrate the system, have them take a couple of test jumps, recalibrate, double check. By that time, you're like, okay, we've got 3 minutes left. So it's really about also making the most of any time you have with coach and athlete. I've been told one more question if there are. Okay, excellent. Thank you so much.